going to talk about why we do that in a minute. But first, what do I mean by factoring polynomials? Well, I have some number. You know, I can break that down into prime factors. So 2 times 24 is 12, 2 times 6 times 2 times 3. Those are prime factors of this number. But an algebraic expression, in this case a polynomial, like x squared plus 5x plus 6, well, it can have factors too. Now, there's no reason to think this, but it turns out that just as there's only one way to find the factors of a number, there's only one way to get the factors of a polynomial. Now, for this polynomial, I'm just going to show you it's x plus 3 times x plus 2, which we can verify using FOIL, which we looked at last time. The first, that's our x squared. The outer is 2x, the inner is 3x. That gives us 5x. And the last, 3 and 2 are 6. Hello. So these are kind of like prime numbers. They're prime factors of a polynomial. We can't reduce these anymore. We would call these like a linear term because there's just one exponent is run. There are factors which are prime in that sense, which are not just linear. For example, if I have x squared plus 1, there's no way I can break that down any further. Well, not in this class, at this moment. So that's the general idea. We're gonna learn how to factor polynomials. Now, before we get into that, I think it's important to know why. Why do we factor polynomials? And I think many of you may know that if I have some polynomial equation where I set my polynomial equal to 0, well, it's really nice to factor something like this. X plus 3 times x plus 2 equals 0. The reason is because of this important property of two things that multiply together equals 0. If I have two numbers m and n, and their product is 0, I know something about these numbers. Does anyone know what it is I know?
One of them is 0.
Exactly. One of them has to be 0. So, in addition, in a polynomial, if either of them is 0, the equation is going to work. So I can reduce this polynomial equation. Here it's, x squared plus 5x plus 6 equals 0. I factor it, and I immediately know that x plus 3 equals 0 will give me a solution, or x plus 2 equals 0 will give me a solution. The solutions being minus 3 and minus 2. Now let's just be skeptical here for a second. There's an eraser. Eraser's way over here. Let's try at least one of them out to make sure that we're on the right track. So if I have negative 2 squared, I'm going to plug in and verify. 5 times negative 2 plus 6. Okay, let's figure this out. Negative 2 squared is 4. 5 times negative 2 is negative 10 plus 6. So you can see immediately 4 plus 6 is 10, and negative 10 is just 0. This idea works even when we have a very, very long, big, complicated polynomial. Okay, now, before we go any further, I'm going to get to what I'll call the rote part of today. By that I mean things that they're so important, they're worth memorizing. I like to de-emphasize in math memorizing things. You want to understand things. And you do want to understand these, but they're so important, you really have to memorize them. These are some patterns. Now, if you've seen one of these before, I'm going to ask you. The first pattern is a plus b squared equals a squared plus 2ab plus b squared. Does anyone see that before? Okay, see shaking head, that'll do. Very important pattern. So for example, if I saw this, x squared plus 2x plus 1, I want to learn how to pattern match that with this. See, I've got my x squared, and I've got 1 squared. So this is like my a, this is my b. And my 2ab is 2 times x times 1. I want everybody to look and see if you can kind of match that pattern in your head. All right? Now, this is the simplest it's going to get, right? If I wrote instead x squared plus 4x plus 4, you might have to work a little harder. Again, there's my a squared. Oh, that's my b squared. And that's 2, the 2 is always there, times this 2 times x, 4x, right? This tells me this is x plus 1 squared, this tells me this is x plus 2 squared. Now, it can get more complicated if what we have in front isn't x squared, right? So if I had like 9x squared plus 4 plus, what would that be? 36, you might not notice it. In fact, you might be the wrong number. Hold on. 3 times 2 is 6 and 12. There we go. So again, here we have 3x squared, we have 2 squared, and 3x times 2 is 6, times 2 is 12x, right? This is 2 times, I can't write it that way. 2 times 3x times 2. So that's, again, this is kind of a pattern matching thing. The reason it's so useful is this pattern, 3x plus 2 squared, is it's going to come up a lot. Now, one nice thing about this pattern is that if you know this pattern real well, the next pattern is real easy. A minus b squared equals a squared stays the same, and the b squared stays the same. And the 2ab is almost the same, except it gets a minus sign. So if you see something like this, but instead of a plus, you see a minus, but it follows the pattern, this just becomes your x minus 1 squared. An aside here, when you see something like this, x minus 1 squared, you can write that as 1 minus x squared. These are the same. Can anyone see why? Any thoughts on that? Maybe it's too easy, or maybe it's too hard. I don't know. X minus 1 times minus 1 is 1 minus x. So if I want to get from x minus 1 to 1 minus x, I multiply by minus 1. But if I do it twice, I'm multiplying by minus 1 twice, which is just 1. This doesn't change anything. So this is sometimes useful to know. If you see a minus b squared, well, it's the same as b minus a squared. It's the square that kind of gets rid of that issue of which way you write it. Okay, so you can even think of this, we sometimes write this as one pattern. We'll write it this way: a plus or minus b squared equals a squared plus or minus 2ab plus b squared. You just have to realize that it's plus, it's minus, it's minus. All right, absolutely the most important pattern for doing factoring. Not everything will be a nice square like this, but this will have other uses that we'll see later. Questions about that? Okay. The next pattern, this is just the second most important pattern. If you ever see a squared minus b squared, does anyone know how to factor that? Has anyone seen that before? Yes?
Wouldn't it just be a minus b times a minus b? Or a plus b because it's minus times?
Yeah, a minus b times a minus b is this guy. Yeah, this is a minus b times a plus b. I want you to be comfortable with this. You should do this yourself in your own free time if you have any question. Let's FOIL this. Let's use FOIL on this and see why we get this. Okay, our firsts are a times a, or a squared. Our outer is AB. Our inner, where we get this negative, is negative AB. And then we have our lasts, which negative b squared. Get that negative. Well, the AB's cancel. So we just have a squared minus b squared. Just like this pattern, this is really important in math. And we're going to see it over and over again. Let's just look at a couple examples. Say x squared minus 4. Who wants to factor that for me? Yes?
Would it just be x minus 2x plus 2?
Mm-hmm.
Okay.
Not hard.
Yeah.
You just have to see this pattern where you have squares. Now, how about that? Someone want to try that? Just a little more complicated, but just have to, again, this is a this is a pattern matching exercise. In your head, you have to go, this is my template. I know if I have a squared minus b squared, I can get a minus b times a plus b. So now I just have to find the a and the b here.
Would it be 3 squared minus 11, then 3 squared plus 11y? Or something, yeah. Yeah.
I don't know where you got the 11 from.
Oh,
That's a 4.
oh, so it would be 11 times 4 equals 44.
You still don't know where the 11 is coming from.
Oh yeah, I'm not sure. Yeah,
I
I don't
like-
know what to do with this.
I like I like what you set up to here.
Okay.
Let's look at this. This is 9x squared,
Mhm.
so that's 3x squared. So we know it's going to be 3x plus and 3x minus. Now, this is 4y squared. What's someone else? What's the b here? What am I squaring to get 2y squared? 2y. And that tells me what goes here, 2y. Let's keep going just a little bit. How about 16 minus 4x squared? Someone else who hasn't tried this. What's my square here? What am I squaring to get 16? Remember in the beginning I told you it's more good to know the squares?
4?
4, AJ? Exactly? Okay, who wants to tell me what I'm squaring to get 4x squared? There's no penalty here for getting the wrong answer. Take a look, see if you can, what am I going to multiply by itself to get 4x squared? You can do it separately, right? What do I multiply by itself to get 4?
2.
2. What do I multiply x squared by to get? What do I multiply by itself to get x squared?
What? Oh,
Well, that's the coefficient.
my fault.
Yeah, that's the coefficient, okay, but you get chimes ringing. It's x, right? X times x is x squared. Okay. Someone tell me, I mean, now I got my a and my b, so what do I have over here as my factors? Hello. What do I have over here as my factors? Be brave, come on, we're all friends here.
2x.
Want to try again?
2x.
2x. Is that where you wanted the 2x?
Yeah, it doesn't matter.
Okay.
Minus 2. I
Hmm?
mean minus 4.
Minus 4.
And then 2x plus 4.
Now,
Oh
there's a
wait.
teeny little error.
Don't you
I'm
switch
glad
it
you made
around?
it because it helps everybody. Whereas here, it doesn't matter. Here it does matter.
Oh.
I have to switch them for minus 2x. I don't really have to change this one, but we might as well, or plus 2x. Okay. Now, anybody who's having a lot of trouble here, I want to be clear, the next thing I'm going to tell you is a really, really neat trick that you don't have to know in this class. What if I had x squared minus 3? And I want to factor that. Well, okay, I got my x squared. Doesn't seem to work, does it? But there's a trick. This is x squared minus the square root of 3 squared. Everyone would agree that the square root of 3 times the square root of 3 is 3, right? So I have my a squared minus b squared pattern. It's just a little weird. I've got a square root there. But sure enough, a plus square root of 3, x plus square root of 3 times x minus square root of 3, those are the factors. I can still do it. You know, kind of a neat trick.
You might do something like that on a test, will you?
Yeah. Maybe extra credit. Okay. All right, so this is our basics. We have these patterns, and we want to learn how to factor things like this. The first thing that you should always check is what we're looking to factor, does it fit a pattern? Now, one of these patterns. Now this clearly doesn't, right? You have to use like the square root of 6 times 1. No, it's not. That's okay. Instead, I think I'll leave these up. Instead, we're going to do something, our next tool is called reverse FOIL. Let's see how that would work. Well, even though it's very similar, I'm going to x squared minus 5x plus 6. Well, the easiest reverse FOIL is when you just have an x squared here. Because I can immediately write x and x. Those are going to be my firsts. The next thing I want to do is look at this guy. If he's positive, then either both of these signs are going to be positive, or they're both going to be negative. So when I go to multiply my lasts to be 6, they either have to be both negative to get a positive, or both positive to get a positive. So I'm not sure yet which of these, but I know it's like this. Now if this is negative, one of these is positive and one of them is negative. Can you see why that is? If you have a negative here, one of these numbers has to have a negative in front of it. Okay. At this point, we know they're both positive or they're both negative. And we look at 6 and we think, well, what are the possible ways I could break 6 up? Well, here's where, again, knowing your prime numbers helps. There's only 2 possibilities. 1 and 6 or 2 and 3. All right? And you might want to convince yourself of that. Okay? Now, since both of these are going to be the same, we're going to have to add these numbers to get the middle number. Well, if I add 1 and 6, I get 7. That's not working. If I add 2 and 3, 5. So that's going to work. So I know these are going to be 2 and 3. But since this is negative, I also know they're both negative. Now, that was a lot in there. I made it sound like there's just some kind of straightforward way to do this, but there really isn't. Really what you're going to do is some trial and error. You're going to try some numbers here, and then you're going to use FOIL to check. Did that work? Let's take a look at another example. I have a hard example here. I don't know if we're ready for a hard example. No? All right, we'll do a hard example. 4x squared plus 16x plus 15. Okay, so the first thing we want to do is check our patterns. Well, 4x squared sounds good. We could make that 2x. But 15 isn't a square, so that's not going to work. And unfortunately, we've got a coefficient here, 4. And even more unfortunately, there's more than one way to factor 4. It could be 4 and 1, or it could be 2 and 2. So immediately we have a bunch of possibilities. This could be 4x and x. That would get me, my first would get me 4x squared. Or it could be 2x and 2x. Now, if you see just pluses here, remember this plus means it either are both plus or both minus. But since this is plus, we know they have to both be pluses. All right, so now we get to the hard part. We've got 15. 15 can be factored in a few different ways. It could be 1 and 15. It could be 3 and 5. Oh, well, that's good. It's only two ways. So we have 2 ways to factor it and 2 different places to plug it in. So at worst, we have to try like 4 different things. Now, we can, also here, we can, whatever numbers we pick, like 1 and 15, we'd also could try 15 and 1. So there's even more ways. But let's start with 3 and 5. Let's try that. Okay? So this is going to be the easier one. If I put 3 and 5 here, my outer, well, I'll write it so I can erase. I get 10 for the outer and 6 for the inner. Oh my gosh. Lucky guess. It was just a lucky guess. If you do some of these, you kind of like to stare at it a little. Sometimes you make a lucky guess. I'm going to make believe I didn't do that. That was just too good. All right. Let me try 3 and 5 here. So 3, 5. So I got 20 and 3. 23, that's no good. We can try it the other way. Why am I wasting my time? Well, I don't want you to think it's too easy. 5 and 3 times 4 is 12. That's 17. No, that's not right. And then I could, of course, plug in 1 and 15 in these different places. And see, it's not going to work either. So, okay, we got lucky. 3 and 5. And if this were an equation, where this is equal to 0, now I just want you to practice this a little. Just we could write this all out. We could write 2x plus 3 equals 0, and then 2x equals minus 3, or x equals minus 3 halves. But I want you to just look at this and think about it. There's a plus here, x is going to be minus, right? You're going to have to subtract from the 3 to get 0. And what number would do that? Well, 3 halves. 3 halves times 2 is 3, so negative 3 halves is what's going to do it. Same thing here. Negative 3/5. Did I say that right? Wait, not 3/5. No. Negative 5 halves. If you see a negative sign here, it's going to be a positive number. It's going to make it 0. So I'm just kind of skipping a step here. Okay, so those are my solutions to this. That I can get by factoring. All right, I want you to try this one. This is a little bit tricky, but that's how we're going to do homework, so you get some practice. Let me go ahead and use this. I'm going to start to off. Everybody have some paper, or need some paper? See if you can factor that. Okay, someone come up with something here? I'm going to let you talk in just a second. But before I do, let me ask this question. The two signs here, what do we know about them? They can be the same, different? Yeah, they're both. We're going to need a plus and a minus, right? Okay. You were going to say?
Yeah, I got x plus 2, then x minus 3. Yeah.
Okay, let's check.
Okay.
Well, the easy part, the lasts are minus 6. Good. Inner is 2x, the outer is minus 3x. Add them together, you get minus x. Yes.
Okay.
Now, can you tell the class how you figured that out? You don't have to, but
Yeah, what I actually did, a way I learned in high school is to factor, you do like an x, then you put -6, like.
I would like you to come up to the board to show people, because I can
Of course.
you know. I know there's a method where, isn't there a method, I never learned this.
Yeah, it's like that.
You kind of like do something like this.
Yeah, that's for
All right,
different ones.
Show the class how you did it.
So class for this one, since there's no number behind the exponent, you only need to do that. This is the x. Then you do the last number, you put it up here, -6. And this one, -1 right there. Then you ask yourself, okay, what two numbers multiply into -6 but add into -1? And that's how you get -3 and 2, because -3 times 2 equals -6, and -3 plus 2 equals -1. So that's how I learned it.
Okay, now, I don't want to abuse your willingness, but can you explain if like this wasn't x squared, how this would get more complicated?
Yeah, like if
Because I haven't seen this before.
yeah, I hopefully I remember it correctly. But yeah, let's say if it was like 4x squared, then you would do this. Let's say how you do this. Then you do this. Then you do x plus 2, so x plus 2, then x.
Well, we don't know it's 2 yet, do we? We only know 6 and 6 and minus.
Oh yeah,
If you don't remember, it's okay.
Yeah,
I'll just-
not far along. But it's like something like that.
Does anyone else know this method?
Thank you.
You're asking if when you make it a 4x?
Well, if I, yeah, let's see if I can, let me see if I can come up with a problem real quick. Okay, I'm gonna cheat here. So, 2x squared minus 3 minus 1 plus 6 plus 5x. Okay. Now you don't know what that was. Does someone know how to use this method? I've seen people do this, I just never learned this method. Does anyone know?
Yeah, it's really easy. I just haven't done it in a while. Yeah.
It's your homework assignment now. If you can remember and you can show us.
Okay, I will. Yeah.
You know, because
I probably
whatever works here is what's good. I myself, when faced with this, would think, well, this has to be 2x and x. And then one of these has to, well, I don't know, this tells me one is minus and one is plus, but I don't know which one. So I don't want to write it in. And this tells me that, you know, each of these is either 3 or 1 or 1 or 3. And then I have to, you know, play around with them. 6 and 1, 6 minus 1, oh, it's 5, oh, okay. So that would work. Plus 6 minus 1. All right. All right. So that's your basic reverse FOIL. It's often, if you don't see a pattern, it's the second easiest way to do these. Now, here's the catch. I wrote this down twice in my notes. Factoring using patterns and reverse FOIL does not always work. Here comes the second version. Factoring using patterns and reverse FOIL does not always work. Sometimes you have something that you can factor, but you can't do it that way. And so we need something more powerful. Gotta, pace myself here. We're going to learn that other method, but not today. All right? Instead, we're going to start on something much worse. You see here, we using FOIL, we're multiplying polynomials. Sometimes we want to divide polynomials. So I might have this polynomial. And I might want to divide it by well, that looks challenging. I don't know if there's anyone here who did not learn long division with numbers. Is there anyone here who is not taught long division with numbers? Don't be embarrassed. I've heard it's a thing. They decided people don't have, they have calculators, so they don't have to divide with them. Okay, good. Because it's, with a little bit of modification, it's the same process. And in some ways, it's easier. Put the dividend, is that the right word? Is the divisor, and the dividend sounds like something you earn in from a stock. Maybe it's the same word. You write it like this. You put what you're going to divide by over here. And then you take a look. You say, well, x plus 1 into x cubed, really just the x into x cubed. What do I multiply x by to get x cubed? It's x squared. This is like, you know, if you're in the hundredths place, or the thousandths place. But we follow the same pattern. We're going to now multiply this by the divisor. X cubed plus x squared. What do we do next? Everybody knows how to do this with numbers. What's the next step? Don't we subtract this? We subtract this. So 6x, oh, I'm sorry, 6x squared. 6x squared, you want to keep these lined up, right? If you have something more complicated, make sure the exponents of the x's line up so we can do this nicely. It's just 6 minus 2, x squared, and then we can bring this down. Okay. All right, I want someone to tell me what the number that goes here. Remember, I want to divide x into 4x squared. I want to know what I multiply x by to get 4x squared. So I'm going to take a look at that. Shouldn't be too hard. I'm going to write that out. X times what equals 4x squared. What do I need here? Yes?
Well, I have a question, why there's 2x squared?
Why there are two x's?
2x squared, under
Two
the
X. She's asking 2x squared. Yeah, that, right there, she's asking that.
Oh, it's because no one was watching and I made a mistake. That's why. What's x squared times 1? Is it 2x? No. Thank you. You do know, nobody's taken me up on this, but you're entitled to come to my office and get a chocolate truffle. Okay, all right, so what's 6x squared minus x squared? Good, it's 5x squared. Wait a minute, 5. Maybe if I give out like bonus points, people will watch, make sure I don't make mistakes like that. So what goes here? No? No, okay.
One.
Okay. Well, if I multiply 1 by x, so I want to get rid of the 5x squared. So I want something here times x, which is going to be 5x squared. Anyone?
5x.
Oh, who said it? That's exactly right. I didn't see who said that. 5x times x squared is 5x squared. Oh, I forget to bring down the 11x here. Now 5x times 1 is 5x. All right, I subtract, I get 6x plus 6. What comes next?
6.
I think you're catching on. Now, in this particular case, we end up with 0, which is what we're hoping for. When we're dividing polynomials, because we want to factor them, we hope there's no remainder. If there's a remainder, we failed. We didn't factor it. There's no remainder. So I know that this is equal to x plus 1 times what we have here, x squared plus 5x plus 6. Now, if I was trying to factor, if I can get this down to an x squared, maybe I can use my reverse FOIL here. Well, I think we did this problem already, didn't we? This is x and x, 2 and 3, plus and plus. Okay? So now I have it completely factored with the help of division. Now, before we get too comfortable here, what's that mean? Let's have 10 minutes. There is another way. Oh. Well, I'll finish my statement. There is another way to do this we will look at. Has anyone here heard of, by a show of hands, has anyone heard of synthetic division? Okay, this one. If you get it, we'll do it Thursday. If you get synthetic division, it's easier. But if you don't get it, don't bother. This works fine. Do you think synthetic division is easier?
Yeah, last year I thought I would always use synthetic. This is kind of complicated for me.
Now, I will say this. Synthetic division only works in some cases. It only works if you've just got an x plus something. But, all right, we'll look at that on Thursday. There will be a homework posted eventually. It's ready, I just have to look it over. Oh, one more thing. I just want to apologize. One of the last recent assignments, I don't know where my head was at, but I made these typos on the page numbers. So if some didn't make sense, don't worry about it. Whatever you did was okay. I'm just saying, I'm sorry. I corrected it. It was, what was it? I don't even remember which assignment it was. But If I make a mistake, it doesn't, you don't get penalized, of course.